Hi, this is Matt Wimmer from Brady Precision, and welcome back to Certificates in Niagara. In this video, we're going to take a look at the details of certificates and dive in a little bit deeper than we did in previous videos. So the first thing we're going to talk about is the requirements that Niagara has specifically for its certificates. Like most things on a computer, there are a ton of different formats that certificates can come in. The certificate format that Niagara wants to see is what's called a PEM file. And that ends with a .pem, like you see there on the screen. If you get a file in a different format, OpenSSL, which is a command line program that you can use on Windows and Linux and a bunch of other operating systems, can be used to convert from that other format to PEM as you need. It's not something that we're going to cover really in this series, but I've included a link here to Rapid SSL Online, which gives you some of the commands that you can run from the command line if you have OpenSSL installed to convert to that PEM file. So within that PEM file, you can have a bunch of different certificates put together, and Niagara needs them to be in a specific order. So from top to bottom, Niagara wants to see a private server key, if there is a key. You might not have that. A public server certificate, an intermediate certificate or certificates. There could be more than one. And then your last piece of that certificate should be your root certificate. And that's what Niagara needs to see. So talking a little bit more about the PEM files. PEM refers to a privacy enhanced electronic mail. It's a format that sort of grew out of email and was adopted more widely. And as we talked about before, it's Niagara's preferred certificate type. If you open a PEM file in a text editor, I like to use VS Code or Visual Studio Code. It's a free application from Microsoft. It's a text editor, code editor. It does just about everything you could want in a text editing program. If you look at a PEM in that, you'll see that at the beginning, there is this line that'll look something like this with a bunch of dashes and then begin certificate. And at the end, there's going to be the same sort of thing, but it'll say end certificate. And we'll look at that here in a slide or two. And this certificate is encoded, which means that you can't read the contents of it directly in a text editor. You have to use a tool like a certificate decoder that I've listed a link here to on sslshopper.com, or you can use a command from OpenSSL like we talked about earlier. But in this command, we're not going to do any converting. We're just going to basically read the certificate. And this is an example of what a PEM file looks like. We've got that begin certificate at the top, the end certificate at the bottom, and our encoded certificate in the middle. Now, this is just a single certificate. The PEM that you'll import to Niagara may include multiple instances of this begin certificate and certificate, depending on the number of certificates that are included in your chain of trust. And if we do, in that previous certificate that we looked at on the last slide, the PEM file, if we decode it, this is all the information that's in here. Now, a lot of this is just information that we don't really care about, but some good things to note are our issuer. This is going to be our certificate authority that signed our certificate. We have a validity time period, not before, not after. You can see that this one is set for 2 years. And then our subject is what the certificate is actually issued for, and it's the information that's in the certificate. We'll talk about that in a few slides. And then the last thing to note here as well is our subject alternative name. So this will list out a bunch of other host names, or I guess potentially IP addresses, that this certificate is valid for. And we'll talk about that a little bit more in detail here shortly. So as we just saw, our certificate includes a bunch of information. It includes our cryptographic keys, like we've talked about in previous videos, and it also includes some information about the identity of the certificate, whose certificate it is. So the first thing, and probably one of the more important things, is this common name. That'll be an IP address or a DNS domain name of some sort. And then we've got some actual physical information, so organizational unit, the organization, locality, state, country, and then we get to not before, not after. This is our time period that the certificate is valid for. So that's our start time and our end time. And then we have our alternative server names. And this could be a bunch of different other host names potentially, or it could be none at all. It's basically just an extension of our common name that this certificate is going to be valid for. And these are the values that you'll see if you go to create a certificate in Niagara. And we'll talk about that in future videos. So our common name, this is how your certificate issuer proves who you are. It's the domain name. Typically, if you're getting it signed by a third party and not an IP address, because third-party CAs typically don't allow you to use IP addresses for the common name. They won't validate against that. They'll only validate against domain names. So that's a good thing to make a note of, is you can't use an IP address if you're using a third-party certificate authority like GoDaddy or someone like that to sign your certificate. It has to be a domain name. And that also means that your Niagara install has to be accessible via that domain name in order to use it. Because if you're not accessing the Niagara install via that domain name and by an IP address, that certificate's going to come up as invalid. And then, as we talked about before, our alternative server names are just going to be addresses other than the common name that the certificate is valid for. Then we have our not before, not after times. These are our effective times for our certificate. Typically, validity is only 1 year, and it's important to make note of your validity of your certificate, because when a certificate expires, all of your users that access your system, whether it's through the browser or through Workbench, they'll know that the certificate is expired, because they'll get error messages saying that, the certificate can't be trusted anymore because it's expired. So within Niagara, we get a self-signed certificate automatically with every install. And that certificate is used for our FOXS and HTTPS connections. But in order to use it, because it's self-signed, our web browsers and our Niagara installs, when we go to connect, don't know to explicitly trust that certificate, so we have to tell them to. You'll get an error, something along the lines of an invalid certificate authority from the browser, and you have to, click through and say accept that invalid certificate authority in order to access it. I think most users of Niagara 4 have probably run into this error message before. So in our browser, we have to pass through that exception. When you're connecting through Workbench, you'll get a pop-up. And then if you're connecting from station to station, you have to go into your allowed hosts in your certificate manager of your platform and allow those connections to happen, or allow those hosts. So the next piece of certificates is getting them signed. You create a certificate, you put in all that information about your identity, but it hasn't been verified by a third party yet, or another trusted party. So what we have to do is get that server certificate signed. And that can be signed by a third-party certificate authority, like we talked about, someone like GoDaddy. And that requires a fully qualified domain name, which is a FQDN, something like, a normal domain name that you throw into a browser. Most signers, as I mentioned before, will not allow you to use an IP address for your common name of your certificate if you go this route. You also have the ability to create your own certificate authority through Workbench, and that's something we'll talk about here in a few videos. And this is good if you have a large site, or if you have a supervisor and a bunch of JSONs, and you're going to be accessing everything through IP addresses and not through domain names potentially. Either way will work, but it tends to be the easiest thing to do if you're accessing everything through IP addresses. The one thing to note here is that it requires a little bit more work, because the root certificate, or your certificate authority, isn't going to be trusted automatically by all of your client computers. because that root certificate isn't in the trust store of all of your devices automatically out of the box like it would be with a third-party certificate authority, we have to add those things in to each one of our client computers that are going to connect to our devices. And then our third option here for getting certificates signed is through an IT department. So if you're working in a large building or a large campus and there's an IT department involved, they likely have an implementation in place already for signing and issuing certificates and keys, using most likely their own certificate authority, which has been deployed to all of their computers and devices already. So this tends to be the easiest route if you can go it. Now, IT departments, depending on who you're working with, can be difficult to work with, but if you can use their existing infrastructure, it's always going to make everyone's life easier. So in our next video, we're going to look at the first of those options, and then we're going to sign with a third-party certificate authority. We'll see you then.